When I wake up in the morning, every morning I say that, today I'm going to do something extraordinary. And today I hope that I can try to share a really extraordinary story that I've been actually chasing and trying to understand for quite a long time. And all of a sudden, 10 or 20 years has passed, this whole thing kind of fell together. So we will discuss this issue of blue sun, the phenomenon of blue sun, and how is that related to what you call the solar activities. And I'm going to avoid politics. Thank you. This is actually what you call the word clouds on the topics that I shall cover. So you can see that I'm really going to put your brain into a real test. And hopefully mine is still pretty much stable as I try to learn more about this sort of thing. But I'll tell you more about what we're going to learn about throughout this whole talk, of course. You can imagine that we're going to even talk about the bees and how the bees actually was able to fool by the plants to come to them, and then so that will help them pollinate the plants around the whole planet. We'll start with this slide. It's actually a live picture. It's actually a true picture being captured by a satellite that is at the Lagrangian point. So for the student, please look up Lagrangian point. It's roughly 1.5 million kilometers away. We actually managed to put a satellite up there thanks to Al Gore. This satellite has been taking pictures now since 2015, actually trying to measure stuff, of course, to study the space environment, of course, and the sun directly. And this is just an image to show you that the Earth system is very dynamical. Of course, what is passing by is the moon. And it turns out that all the orbital solution proposed by most of those folks from IPCC who are so sure that they are right has not even considered the moon and the Earth together. And then this is just a cartoon picture, but just to try to illustrate for you that if you really believe that this sort of picture is actually adequate and correct to explain the phenomenon that I'm going to try to explain, I think we are wrong in that sense. So we need a lot more subtlety, a lot more details to try to explain what we are trying to learn about. Because nature is indeed truly very complicated, and there's a lot more to be said about that. I'll start with the motivation slide. It's basically a physicist that is very well known for those of you who do not know him. His name is Richard Feynman. He's one of the greatest physicists from America, I would say, of all time. And he's a professor of physics at Caltech. And our friend Art Robinson actually took a class also from his series of lectures. Not from him directly, of course, but from the legacy of his lecture series at Caltech, offered for undergraduate. But here's what he says on this book that he had published, the Feynman Lecture Series on Physics, who trying to point to the point that perhaps that, the problem of climate could be really handled by this problem of just transfer into a mathematical problem, where he say that the mathematics seems to be a bit difficult at that time, but perhaps somebody will realize this is important and really works it out, okay? And of course, despite what Feynman say, I have to say I disagree with him, but mainly, Professor Feynman is referring to a phenomenon like this. It's actually atmospheric turbulence, which is one of those great unsolved mystery that has been puzzled, I guess, human mind for a very long time. If you don't like laboratory experiment, this is actually an image of how we can see it on Jupiter red spot. These flows are pretty much chaotic in some sense and turbulence, and it's really still defy physical description in the sense that Professor Feynman is referring to. The mathematics and the physics are really hard. In nature, you can see sort of things like that too. I mean, it's not really easy to be able to go down to the level. Joe, I hope we're not trying to predict things like that, right? It's a bit difficult in that sense. But here's my answer to what is climate, right? What is climate, I think, would involve something like mathematics. There's no doubt that Professor Feynman has a great insight. But it involved many, many more things that we were going to cover throughout this whole talk, of course. Astronomy, solar physics, geology. Geochronology is basically how you define time. Geochemistry, sedimentology, tectonics. We were going to talk about earthquake and volcano. Paleontology, paleoecology, all of that. And history, of course. And then, of course, as usual, for those who really trying to suggest that this carbon dioxide in the atmosphere is the only factors that are going to govern the whole climate system, I think it's a bit ridiculous. And we're going to hear a lot more from our friend right here, Joe Bastardi, and guys like David Legates, and even Joe Lam Kula will be able to tell you more about that. This is just a very artistic picture about blue sun. It's actually a very interesting image generated by what you call artificial intelligence. People has been trying very hard to try to see we can teach a computer how to paint like Van Gogh, right? The famous painter from Holland. And this is just one of the examples to try to start this idea of blue sun, just to introduce you. My source of motivation was actually finding this paper from history literature basically. It's this professor from Germany. He's actually at Italy now, Martin Bauch. I don't know how to pronounce his name, so but apparently that this phenomenon of blue sun was very well observed from history. And it's been known actually. So one of the basis is basically from a quote like this, from a chronicler at Heidelberg. For this particular quote, it's clearly that they observed that people has been documented this blue sun appearing, the sun in the sky appearing to be looking like blue. And no one, of course, know at that time what it is. And they even talk about comets and things like that. And then in Italy, you observe more or less the phenomenon. But now this chronicler have more precise timing. It's basically around 1465, around September, where he really sees that in the skies, the sun's color all of a sudden changed to blue according to this observation. And then from noon to the evening, lasting quite a few hours, that you can see the sun is turning blue. And then also from northern Germany, you can see another observation who says that the sky is looking blue. Why is that? And the sun rings and lights all looking blue in some sense, and sometimes even white and red. And then, of course, if it's just purely European phenomenon, then it would not be so interesting, because we're seeing this phenomenon all over the planet. And here's an observation from Guangdong, which is actually a year earlier, 1464, right? That's talking about stuff falling down from the skies that look like black rice and black millet, that black balls and all this information, basically, that appear to get a hint that maybe it's related to fires or some kind of volcanic eruption. So our goal is to try to explain what this phenomenon is all about. And I'm trying to say that if you even just studied the volcano or forest fire, that's not adequate. Apparently, you can actually explain it in terms of the sun's activity. This is just a little fun cartoon. If you look carefully in details, everything looks very interesting in some sense. This is just a microscopic picture of how a grass near the seaside look like. But what is really known about the phenomenon of blue sun, right? Is it really purely volcanic eruption? The unique guys that does this? And then if so, where is that volcano? So we're going to point that out. But the first thing we notice is that we already can see blue sun phenomenon very easily if we just move to the Mars, if we started to colonize Mars, for example, go live there. I mean, it's basically a battle of atmospheric phenomenon, right? Something related to how the photon, the light of the sun gets scattered by the medium. For the Earth, it's basically scattered by the medium that is very, very small, the nitrogen and the oxygen molecule. For planets like Mars, has a lot less gravity, of the order of 38% less than the Earth, and then a lot of dust particle. So this light, basically, we're talking about light scattering of particles. So this is basically called Mie scattering problem versus Rayleigh scattering problem, where you can see that the light appears to be quite blue. So physically, we more or less understand this sort of thing. But is there something deeper that we can learn here? In terms of scattering by dust particles, I mean, we can even see such phenomenon in let's say, during a dust storm. Here, a specific event that recorded 2009 in Brisbane. And then, of course, in the Great Pyramid, you can see that phenomenon documented too, around 2006. And here, we actually was able to trace it to some sort of forest, some kind of fires that's being burned, I think, after all the harvest is being done. And then there is also a very well-documented phenomenon of blue sun occurring around September of 1950. Since we talk so much about forest fire, I wonder anybody know about this particular phenomenon of forest fire? This is actually one of the biggest forest fire ever occur. This is just a technical buff for people that try to say that they actually have some instrumental measurements. But apparently, this phenomenon can easily be explained by a very big forest fire in Alberta, Canada. And you can see the phenomenon is being well documented. But the author of this paper trying to explain that, is not quite just, is not unique. We have seen it before, first of all. And then you can see it during dust storm or volcanic eruption, right? And then trying to link it to famous eruption during Krakatoa, which is 1883 from Indonesia. We can see that. We'll talk about that in a minute. But the bottom line is that for the September 1950 phenomenon, it's actually one of the biggest forest fire from Alberta, Canada. As you can see, it burned about 3.5 million acres of this boreal forest. And in this particular case, actually, it's very interesting to see how the government is actually treating the problem of saving forest fire compared to the situation today. Apparently, this thing occurred in an area of the river where there's no human living around there, so they actually let it all burn out. So it's very different treatment from what all this cry wolf every single day now that we hear from the forest fire in the West. And then from the study of this particular event, they're even leading to story like pyrocumulonimbus. Joe, heard about this one? Fire, shooting, stuff all the way up. So this is another one of those related phenomena to try to explain how you put particles way up there in Jack, all the way to the stratosphere, 50 kilometers up or so. So for example, this unexplained blue sun phenomenon probably could be caused by an event like that, a forest fire somewhere in Boulder that you can see. And then now a brief lesson on Chinese as well. You actually apparently seen this stuff also in Hainan Island. So it's very, very clear that, and except how to explain it. So you see a picture like that, all sorts of phenomenon. And then according to Dave Legates, we need to learn a little bit Chinese in this particular day. So oftentimes on the internet, you will see that people say blue sun, but in Chinese, they say green sun. So it's very confusing in some sense, so beware. So obviously that is not blue sun, right? So beware of the fake news on the internet, as our president will warn us. So the true picture should be this one, because Chinese character in blue will look a bit like that, so beware. Now we go to the volcanic phenomenon. This is actually a nice sketch of Krakatoa in 1883, right? And recently, as of a few weeks ago, in July, this Krakatoa in Indonesia, by the way, started to go alive again. So this guy started to erupting a little bit. But the phenomenon of this is well documented in historical painting. This painting, I hope most of you have seen it, is by the famous Norwegian painter by the name of Edvard Munch, right? And he, although painted this around 1890s, but this thing can be actually traced to Krakatoa, okay? So this is just a different rendition of how colors are presented in those paintings. So interpreting a photograph, a painting like this to physical phenomenon is not so accurate. That's a bit of my warning. But to trace it to the Krakatoa phenomenon, Edvard Munch himself actually clearly stated that this is actually related to something that is related to Krakatoa. And it does. In 1883 at least, there are people in a newspaper at least noted that there were times that during the time, certain period of time, that you can see, look at the sun and it looks a bit blue, right? So again, very, very active now, this Krakatoa. So now look, what do we have to learn to understand this phenomenon? We definitely need geology, isn't it? We need to know all these other sedimentology and glaciology and oceanography even, okay? And this just happened to be something that I studied and wrote about it many years ago, some 15 years ago, and it was about another volcanic event that is 1815, that is very, very big event called the Mount Tambora eruption. And this is just an example of a most recent picture of Mount Pinatubo in Philippines, showing you that indeed volcanic eruption is able to spew huge amount of dust particle and gases, and especially sulfur, of course, to bring it all the way up to the stratosphere. And then the sunset phenomenon is very, very interesting. It's actually, again, another example of all the light scattering phenomenon on planet Earth. And for Tambora, clearly you can see the evidence there. So the question that we really want to know about is that where is the evidence for this 1450 or 1460s sort of a Kauai eruption, okay? And just a bit of a phenomenon of this 1815 and 1816 phenomenon from our own founder of the Constitution, Thomas Jefferson, actually recorded the phenomenon himself. It was a bit funny when I wrote to the custodian of the Thomas Jefferson Library to say that, can I quote this, can I use this graph? He said, this is public document, anybody can quote it. So I'm very happy to report to you that this is he said that this is for free use, so there's no copyright or whatsoever. So indeed, 1816 was a very interesting phenomenon. For some of you may not have heard it. Can you imagine that during summer of 1816? So Tambora happened in 1815, right? But a year later, those ash clouds started to move north and shielded out all the cloud. 1816 in the summer, you actually found recording of people saying that there's snow in Vermont and all these different places. So it's very spectacular phenomenon. It shows you how powerful nature is, right? You obviously think that if CO2 can do that, good luck. Now I come back to the event itself. This thing was actually observed from ice core. Because if you study ice core, if you study the chemical element like sulfur, for example, sulfate, you will see that these things are well documented from, I should say, it's not only East Antarctica, it's actually West Antarctica ice core. You can find that too. And then if you notice that 1815, you also can see the Tambora event, right? And then from the most latest publication, all 6 or 7 of this ice core Antarctica, you clearly detected the 1458 event that is called the Kuai. I don't know how to pronounce that eruption. And the location of this place has actually been identified. It's actually near the Vanuatu Island chain of island, and the north of it is this island called Epi. The other one is the Tongaoa. Remember, it's not Tonga, it's a very different one, Tongoa, right? And they actually find the evidence for the caldera around this particular eruption. This is probably a submarine type, which means you actually erupt under the ocean, but it's very, very huge, so the signal is very, very clear, and you detected just about everywhere. And now for Cork, there's this group from University of Connecticut was able to find some evidence of anomalies from this, because these things are bringing stuff all the way, magma from deep inside the earth, so they are very enriched in some sense of a platinum, for example. They were able to detect in about 5 out of 8 of this location around US and even in the Caribbean, and even all the way down to Iceland, they were able to detect the presence of platinum anomaly around this eruption time that is about 3 times higher than what you observe on the crustal value. So it's indeed, platinum could be a very good, this is the evidence of where they found this, right? So 5 out of 8 locations, they were able to, you basically drill down and get all these sediments, and then you study the platinum concentration. You are able to find that during the time of Kauai eruption, that this thing is actually anomalously high, so factor of 5 or so, right, higher. And around Kauai, actually around Vanuatu Island, there are now volcanic activity is beginning to be active again. I will put in context, of course, whether this has anything to do with something we can predict or understand even. So now, you already see, right? You have moved on. How many subjects in about less than 10 minutes, right? So please be patient, there are a lot more. So now we have climatology and meteorology we have to worry about. So, if this event is so great, right, can we see them in climatic record or all this sort of stuff? Yes, we can. From 3 rings, we clearly see that the 1460 event is very clearly documented, okay? The top chart is actually showing you the 3-ring reconstruction of the temperature, of northern hemisphere temperature. And it's clearly documented that it's a very cold time for northern hemisphere on average. And then, yeah, this is 3 rings, okay? The 3 rings result. That is very clear, it's quite exceptional compared to other times. And then from ice core, from South Pole, Dome Fuji actually is not South Pole, it's South. This is the Japanese group, and they were able to detect clearly a very cool peak, even all the way down in Antarctica. And here is actually even more spectacular. You were able to detect this thing not only at the surface, you detect actually in sediment that represent the water temperature of about 200 meters down, okay? So you are able to see the dip as well of the cold temperature. In China, if you study the stalagmite in the cave, this stalagmite and stalactite stuff in the cave, that you are able to see that there's a clear cold dip around Beijing area, around that time, 1460, a very sharp drop all of a sudden. Again, it's the abruptness and it's the depth of this cold that is actually make it very interesting, isn't it, for climatology and meteorology. In fact, I challenge Joe Bastadi to try to figure out a scenario in which we can figure out what the meteorological condition will be like based on all this information. Even glaciers in Antarctica near Brook Range, you can study sediment and then you can measure some quantities that you can actually try to see whether there are any information on how the glaciers are advancing or retreating. So around 1460, you do see that actually it was actually accumulating mass in Alaska, the glaciers there. Even from lake sediment from let's say Venezuela, the Andes region, you can see evidence for glacier accumulating mass. So this is actually occurring in a time where in a later I'll explain that it's related to where the sun activity is very, very weak. Down to even places like Jamaica, you can see for the drought proxy, you can see that there's a very, very significant droughts in the Jamaican droughts area. Before we go any further, that I explained to you, this has all related to the sun, I want to tell you a bit about how nature gives us blue light, right? One of the examples here that's very well-known one is bioluminescence. This is a very amazing phenomenon that happened, that just captured this in La Jolla quite recently, actually, beginning of, in May of 2018. It's actually related to all these tiny dinoflagellate, right? These tiny sea animals that do this sort of thing. It's really amazing with the wave running, and then this whole thing is just light up completely. And now we come to the bees stuff. I mean, why blue light in the atmosphere is so special? I mean, apparently, the flower, who of course is just sitting in one location, if they really want to propagate their species, they just cannot move around, walk around, do whatever they want, right? And spill their pollens. Apparently, that this is actually quite a very interesting study that just appeared last year. That on the surface of all these petals, of all these different types of flower, there are, you look very carefully, it's the size of these nano size of residuals that actually create so that the light, when it's scattered, it creates this blue haze around where the bees apparently is seeing it, so it go over there and then take the pollen and spread it around. This is another one of those wonders that we can actually learn a lot more if we study science carefully. So I find this to be very interesting to share with you. No doubt that we have all kinds of phenomenon in the atmosphere. This is called the electrical discharge from thunderstorm. This is sprite events all the way up in the ionosphere. And then another well-known thing is basically, of course, the aurora. But aurora, you can see, you never see them in blue light in that sense, because energetically, it's much easier to make red and green aurora than to make the blue one. But even the blue one has been seen, of course, according to this pilot who's been flying around, and then around April of 20 of this year, was able to see this thing all the way up, and that he was able to see this blue light sort of a phenomenon. For the aurora stuff, there's nothing magical, by the way. Science is not about magic, right? We need to explain it. It's come from that particular nitrogen or nitrogen ions, the molecules, the blue light that's be able to produce by that. If it's oxygen, it will be mainly in the area of green and red or yellow, a little bit yellow. So that part is also well understood in a lot of sense. So now the question I want to pose, anything unusual about the sun and solar activity, right? I've been studying the sun for a very long time, and this phenomenon is really curious me and very interesting. So I try my best to tell you what I learned so far. So you consider this as what you call science progress update for you. So indeed, we need to know more about solar physics. The first thing when you talk about the sun is that I always couldn't be more motivated than to put this sort of a quote from Galileo Galilei, right? The well-known guy from Italy who didn't invent spaghetti, unfortunately. It's the Chinese that did the spaghetti business. Well, he called the sun most pure and lucid, right? But then he realized that there's all this corrupted little dark spot that is appearing, It is spotted and not pure. So he made the latter claim. And this is just showing you that in the 17th century, in fact, this is not by Galileo. Galileo was not smart enough, by the way. He was looking into the spyglass directly, so in fact, he was blind throughout the rest of his life. But this is by Christoph Scheiner, another Jesuit, who actually was able to learn how to project the image of the sun using this tiny little spyglass, right? And show the image of the sun and realize that the spot is actually inherent to the sun. It's not related to Venus or something like a moon appearing in front of the sun, so they make the spot, the surface on the sun look dark. And here's a small little treat of collection of all the Galileo observations from 1613 and animate them, where he plot them. He was already smart enough, he realized that the sun actually is not actually rotating at, like 90 degrees here. Is off by about 7 degrees off from the orbital plane. So he's already got all the physics correctly when you start describing things carefully. But in terms of sunspot, this is what is known, okay? Taking all the data from 1610, from Galileo started, he actually saw a lot of sunspot. And then by the time we reach about 1650 to about 1710 or so, there's a period called Carbon-14 Minimum. Essentially, there was no sunspot, okay? So in fact, the observer in Observatoire de Paris find it very curious. Maybe Galileo is lying to us. What happened? Like all of a sudden, he reported a lot of sunspot. When we look into it, there's nothing. So what happened, right? Actually, this phenomenon is well known. it's actually credited to this. They were being labeled to be a Maunder Minimum. So just to explain to you, these are the two people that actually husband and wife team that are very, very dedicated sun observer. In fact, they are the one that took the photograph daily when it's not cloudy from 1876 to until they retire in 1928 or so, right? And then later it stopped, the program stopped in 1976. But here's how you explain the Maunder Minimum phenomenon. As you can see, the sunspot appear during regular time. The sunspot appear usually in high latitude region, mid latitude, 40 degree or so. And then the wave slowly progress towards equator as time progresses. But this is during regular time at the bottom panel. But the top panel during Maunder Minimum, apparently the sunspot never appear in the northern hemisphere. And then also the region in which the spot appear is very narrow, 20 degree the most. It's not 40. So it's very restricted and appear there. So this is at least observationally we know. And my good colleague from Observatoire de Paris called this the broken butterfly wing, which I find it to be very poetic. Yes, the Sun King was around there. So this is also related, according to people, is basically related to Louis XIV, right? Who actually was reigning during that period, 1643 to 1715, where the sunspot don't dare to appear. The funny story that you all probably heard from my old colleagues, Sally Balunas, who's my favorite mentor. Actually, we work on Mount Wilson Observatory project. The telescope, the glass that we use actually from the same people who built this city of, this hall of crystal or light in Paris, right? That built by Louis XIV. So the summarize is that whoever wants to read this book, please ask me. I'll send you the PDF file to read. And I wrote this thing just to honor those people, obviously, to try to explain what Maunder Minimum is in terms of what we understand so far. And I think 14 years later, I have nothing more to add on that. So at least it's summarized in that book. But today, we want to describe the 1450s or 1460s sort of phenomenon. It turns out that there is another period that is much more extensive, much longer even compared to Maunder Minimum. It's called the Sporran Minimum. Okay? This is a plot of the sunspot series from about 2,000 years ago until now. And if you want to know more about that, I'll explain to you later, of course, but it's just too many things that I cannot explain in one 60-minute talk. So Gustav Sporran is this amateur also who retired and then started to observe the sun carefully. In fact, he was the one who pointed out Maunder Minimum being a period where there was no sunspot, but then somehow another person named it in the wrong way. I think that period should be named after Sporran Minimum, but now it's, in the sense of history, it's now called as Maunder Minimum, and Gustav Sporran was one of the big contributors at that time. I don't think I should explain this to you, but the sun is indeed quite a complex structure. It's actually a thermonuclear generator. This is the source of the energy. In the beginning, people were suspecting all sorts of things, that maybe there are oceans inside the Earth's core, the sun core, or even Professor Stephen Hawking, who passed away, who used to speculate that there may be a black hole inside the sun. But by today, we are very firmly understood some of the physics inside the core, the top 20% of the inner core. And then all the problem we have been studying is actually near the outer 30% of the surface, which is called a convective zone, where you form all this magnetic field and sunspot and so on and so forth. But the sun has not only the light radiant output, there are a lot of phenomena like they spew out charged particles actually. It's basically electrons and protons, right? Mostly protons, right? And all this higher heavy nuclei. One of the examples is during a solar flare event in 2005, for example, that this event can really travel very fast. And then if you look at this in X-ray, by the way, X-ray cannot be done until you put the satellite in the sky, right? Because it's filtered out completely by the Earth's atmosphere. So this one is actually modern technology that allow you to see phenomena like corona hole. This is nothing but just field line, magnetic field line. Imagine Earth is a bar magnet, right? This field line actually come out and extend all the way to Earth, by the way. So we are living under the heliosphere in that sense. So we are totally controlled by the sun in a lot of ways. For historical reason, I wanted to explain to you, by the way, because of the energetic balance between the magnetic force and the radiational forces, long ago, there was a professor from University of Chicago by the name of Eugene Parker, who is also my mentor, was predicting that there ought to be a continuous outflow of material from the sun. It's called the solar wind, he named it. And when I pointed this out, this observation from the Tang Dynasty in 6th century to him, he was very grateful. He was very happy to say that it's amazing history that many people already know about this sort of thing. This description from 635 is really interesting, Because he explained that in general, when you have a comet appearing in the morning, its tail is always pointing to the west because the sun comes out in the east, right? Always the opposite direction. And then when it appears in the evening, it points towards the east. And then this is a constant rule. If the comet is north or south of the sun, the tail is always pointing away from the same direction as the light radiating from the sun. This telling you that the wind is blowing out continuously, and then every time the comets come, the tail will be pointing anti-sun direction, right? It's amazing detailed description by the Chinese as long as, so many 100 years ago. So I point to this solar wind because it's very, very important to go to the next step about how to explain a lot of this phenomenon that we want to study. Because the solar wind will interact with a lot of this very energetic, even more energetic than the sun. It's called the cosmic ray that is coming from the galaxy, basically, from supernova sort of explosion stuff. This stuff is coming in very fast and interact magnetically with the solar wind, right? So how strong and how weak the sun activity is will control how much of the cosmic ray penetrate the Earth. In fact, you see it right here, if you have a detector, you actually can measure the amount of ionization caused by the cosmic ray who actually penetrate everything, okay? And that's very, very important to know that. And I'll show you a measurement that can give you information on that, on the sun activity. So galaxy is one of the good way to think about this cosmic ray business. And here's one of the proof. We actually are able to measure this isotope called beryllium-10 in ice core. This is actually from a particular ice core in Greenland that show you that exactly around 1460, there's this very sharp peak, which show you that because the solar wind is weak, right? So a lot more cosmic ray coming in and produce this huge anomaly of the beryllium-10 being produced. It shows you that the sun activity is weak, like what we call the Sporran Minimum. Another evidence from South Pole. Notice that these are all very sharp, direct, one point sort of situation. Here's another example. But here, I also wanted to point out that in scientific literature, one really have to be careful. There's a lot of also scientists that is not so scientific in that sense, because they propose that there is a supernova explode very nearby around that time. But when I look it up, you check, it's just not there. This is what you call power review system, right? This is just not right. Those guys are not as serious as I think they are. So one has to be careful all the time about how to filter scientific information. That's another lesson that we can learn a lot from DDP. So Sporran Minimum, here's Dome Fuji. Dome Fuji result is also very clear. They make various measurements. They clearly show that there's a very sharp peak of production of beryllium-10 and even carbon-14, which is this radioisotope, right? That can be only made by cosmic ray interaction with the Earth molecules. And from my good friend in Japan, who actually think that the Earth is bigger than the sun, it's very, very interesting perspective, right? This is the view from Earth Sciences. And she actually is a tree-ring expert. Her name is Hiroko Miyahara. She almost came to work with postdoc with me at my workplace. Unfortunately, politics doesn't let that situation happen. But she's a very good expert in studying carbon-14 in tree rings. So essentially, you collect this tree that is old, right? And then you try to measure the carbon-14 in each anode layer that's formed. That's what she did with her colleagues. So they found two places, one from the temple in southern Japan, another one in Yaku Island. Yakushi Island, where they found in 700 years. That one is enough to study Maunder minimum, the top one. The bottom one, they can study the Sporran minimum. And the first thing you check is basically you can detect this nuclear bomb detonation that we can find around 1960, right? Or so. It's clear that these things are imprinted there, so you at least verify that we are doing the right thing. So from measuring using equipment like this, they were able to detect the carbon-14 anomaly. By the way, the changes is really, really large for the Sporran minimum. For the tree rings, they were able to cover 1410 to about 1610, 200 years of measurements. That very, very fine details that they were doing. So she's a very careful worker. So I believe a lot of her error bar is a real error bar. So she's actually a very good worker in that sense. So they really confirm that the phenomenon of Sporran minimum from about, I would say, 1430 to 1510 exists. So about 90 years long of very, very weak solar activity. That's what I'm trying to say is related to all this phenomenon you observe. This is just a bit summary of the details that I wouldn't explain, but we are actually trying to study the structure during Sporran minimum. The question is, does the sun activity completely stop? Her answer is that no, the sun activity is still happening, okay, except sunspot didn't appear. So it shows you that the sun has many, many more tricks in its pocket that we don't understand yet. So this is just confirmation of the Sporran Minimum by measurement from different area in Washington State. The trees from Washington State, British, England, New Zealand, North and South Island, you can actually detect the very clear signature of Maunder Minimum and Sporran Minimum using carbon-14 in 3 rings. But there's even more spectacular method to try to confirm, to nail it down so that we know exactly. It's basically to study this cosmic ray. As I told you, it came all the way in, actually, if it's not stopped by anything, that they produce the carbon-14 directly from breaking the ice matrix, the oxygen in the ice matrix, directly. So it doesn't depend on magnetic field of the earth. It doesn't depend on the filter and how thick the thing is. So this is a very serious measurement, but the problem is that it needed a lot of ice. So we asked our National Foundation to do some more serious work instead of doing all the junk work that I see out there. But this is the one that's very difficult to do, but it's done by the late Professor Devendra Rao from UCSD that was trying to explain that actually this is a very unique method of tracking. He actually was able to get a little bit of NSF, give them a huge amount of ice so they can do this, because the signal to noise ratio is also a very difficult problem. But they were able to get this ice core from South Pole that was able to show you that, during that region, they were able to see some nice signature. But in science, all game is like this. You try to predict the amount of signature you expect, and then what do you see? All measurements tells you that the first thing I want to point out, yes, you can clearly see the 1460 peak in beryllium carbon-14. You cannot see directly the Maunder minimum, but you see the daughter minimum, a very broad peak. Another phenomenon is that when you are weak, okay, you can detect a lot of this, but when you are very strong, magnetic shielding is wrong, the carbon-14 will be much, much reduced, isn't it, right? So can you see that? You also see that in this particular ice core. This one, I do not believe that it invalidate the model, but it's just simply because they need more sample, the finer sampler. They don't have enough sample to do this work properly. And Professor Devendra Rao already passed away. So I wonder who will take on the job. So we see evidence indeed for solar maximum. So indeed, the sun is not only can go weak, but it can go very, very strong at some time. So around 1050 to 1200 AD. And then you clearly see the Sporran minimum, which is the subject that we're examining today. So even more story, which is to talk about the historical evidence, right? Because not only that, people observing the sky phenomenon, you can also see that about the sun from historical phenomenon. One of the famous one is actually by this Chinese emperor who actually reigned for only 9 months before he got a heart attack and died. But he was able to describe this sunspot phenomenon. But of course, as you can see, apparently the Chinese brush is very thick, so he make the sunspot look a bit too big. So, so that's not a very scientific way to learn anything. But around 1425, there's clearly observation of sunspot around that time. These are all naked eye stuff, okay, remember? And then from Korea, you can get information from study of the aurora activity. This is the stuff that you study from the north and the south. You can see aurora activity, right? Apparently, the Koreans are also very keen observer of the sky. They have a very long record for almost 1900 years, right? From year 1000 AD until 1900, for example, here, 18th century. It's clear that during the time when the activity is very weak, you don't see much aurora, actually, around Maunder minimum and Sporran minimum especially. Maunder, there's still some activity, but Sporran is slightly more clean. This is not because nobody was watching. Actually, they were watching and then they didn't see it. So that's another very interesting phenomenon to confirm that you can see from the Korean record. And now we're going to move to something even more spectacular that I call it a study of orbital theory of most of these things that I wanted to explain. So it requires astronomy, no doubt about it. Well, historically, in terms of artistic representation, this is a very big breakthrough from the Joseph Wright of Derby, who actually placed the sun in these orbs to try to explain the regularity of the whole solar planet system. But the most important work that I try to report here is based on the grace of my good friend from Argentina by the name of Rodolfo Cionso. This is another one of those amazing characters that nobody knows about him until I actually studied and communicated with him about the amount of work we can do together. So this is indeed moving on to the modern study of how the sun and planet interact and cause the solar activity to do all these things that we're supposed to explain, right? So again, remind you that from the sun, from the Mars, the sun really looked blue. And to remind of the consensus of this atmospheric carbon dioxide causing climate change, I want to remind that in 1919 at least, there's 100% consensus that the the Martian canals is real, right? So no doubt about that. But we all know science doesn't work by consensus. So another one of those consensus that I want to make a statement that sometimes can be shocking to a lot of people. Copernicus is not entirely correct, right? The sun is not the center of the solar system, right? The solar system is indeed not the center of the solar system. Our friend, our great scientist, Isaac Newton already realized about this. He basically explained that indeed, that there is actually a barycentric center of the solar system because we have 9 or 10 planets, what have you, right? All these different gravitational field and the motion are affecting each other, okay? So the sun is actually moving around. But Newton already know that it won't move too far away, but it still moves. That's the whole point. And here's a cartoon way of looking at this, right? That imagine Jupiter or Saturn is out there to perturbing. The yellow is, of course, is the sun that is moving around. Of course, for this kind of rendition, you actually are exaggerating the amount of change a little bit. And here's a solution of plotting where the center of the sun from about, I would say, 1944 to 2030, to try to show you that the sun is actually the center of the sun is wobbling around this whole center of the solar system. So this is a very interesting orbit, right? It's showing it's moving around everywhere. To put it in context, this is what happened, that the sun, so each of the line is showing you the center of the sun being perturbed by all the different planets, right? The different configuration, relative position of all the planets, including the Earth, right? That's showing you that the movement of the sun is actually not very small, by the way. It's of the order of 3 million kilometers, the whole area of this box that is moving around. It's quite substantial in that sense. So it's about 4.5 times of the solar radius. So it's a very big movement in that sense. And then if you look carefully, based on my colleagues from Czechoslovakia, her name is Ivanka Chavatova. She actually pioneered this study. She realized that when you look carefully in the orbital solution to all of this, that you can categorize into what you call the ordered orbit versus the non-ordered orbit. The non-ordered orbit essentially explains all this solar minimum that we see in the sunspot record, from Wolf to Sporran to Maunder to Dalton, and to even the modern minimum that we're observing. And then during regular time, the orbit is very specific pattern. They call it the trefoil pattern that is very, very clear. And here's a zoom in on the pattern where it's very regular orbits around 1906 to 1955. And then the part where we are trying to study where the orbit all of a sudden going, in fact, even go into what you call the retrograde motion, which is really, really interesting. And then our job as a scientist is to quantify all of this, right? So this is now discussing the work that I did with Sionso. And we produced this work that I think nobody noticed yet, but I think, again, I didn't want to go out to explain this phenomenon. It's just that we have done this work long ago, and then all of a sudden I can see it can easily apply to this phenomenon of blue sun. So we have already a solution, by the way. We found that Sporran Minimum is indeed a very, very special period. Now is the breakthrough of the concept. As you know, Sporran Minimum, I use the word Sporran Minimum, but nobody knows when does it begin, when does it end. And I want to propose to you, using this solar orbital theory, we can explain that it's basically better start from about 1430 to 1520. There's a very specific phenomenon how this thing happened, right? Because of depending on how Jupiter and Saturn and Neptune and all of that is affecting the climate. Here is just an example. During Sporran Minimum, you can see the ordered period for 60 years and then disordered period for quite a long time. So this whole thing recycled in about 180 years. And this is showing you, of course, the plot of the radius position of the sun to the velocity to the acceleration unit. So you can show that all kinds of things happening. And then the question is still this: so what? The exciting thing for me is that you actually can trace all this and then can even find evidence that earthquake and volcano are affected by how the sun and the earth are going, being pushed by all these other planets is going around. So this is another very exciting thing that I just saw that I find it exciting. Here is just an example of a cartoon of Earth going around the sun, but I told you that at the beginning, the picture that the sun is not moving is not correct. This is exaggerated, of course, right? But even the tiny planet like Earth, we are actually affecting how the sun should move around the center of the solar system. And the region, instead of millions of kilometers, it's on the order of only 1,600 kilometers, okay? Very tiny, tiny amount. But it has some relevance to this whole theory. So the first evidence I want to show you that is very exciting, and I already showed this evidence a year or two ago, which if you count all the volcanic eruption from the Smithsonian volcano records, can you see any pattern? The first pattern they found is actually indeed that during January to about June or so, that actually there are more volcanic activity occurring. And then when it's during the period from about June to about December, you actually got lower activity, volcanic eruption. And this apparently is related to just how much the sea level is loading the tectonic region, right? How much seawater. And it's of the order of only plus or minus 10 millimeter. That's small amount. If you guys know anything about the ice ages and the cycles and that, those are 120 meters. What I'm very excited about is that this thing shows you that from seasonal scale all the way to the famous Milankovitch orbital theory to explain the sun-climate relation, up to ice ages, the one that on 100,000 time scale, it's all can be explained by that whole phenomenon. And the thing to stress is that from basically July to January, it's going towards, because of the relative position of the Earth to the Sun, you're actually doing maximum squeezing the tectonic region. And then when it relaxed, all the volcano activity started to be prevalent. Okay, so this conceptual picture actually kind of worked. And even more exciting is that before I came here, I asked the same question, can we see it in earthquake? It turns out that in very deep earthquake, the one that is actually about, let me see, magnitude about 7, greater than 7, but deep earthquake, the one that is actually about 500 kilometers deep down. Most of the earthquake is very shallow, okay, in the top surface, like 10 kilometers. Those are very damaging, right, those earthquakes. But it turns out that there are some regularity in this. You see the seasonal cycle in this. But is this the model of the Earth that look like this? This is based on a fruit from Hawaii, by the way. But the real picture is much more complicated, right? You have deep layer, all these fine details that you need to know. But the volcanologists and the earthquake people actually realize that this is actually for the evidence of deep earthquake having the seasonal cycle, because during the northern hemisphere summer, for example, you can have 2 to 3 times more deep earthquake event compared to, let's say, the other period. So this whole thing is really, really interesting to be able to tell you that there are something related to the sun and the earth orbits around, that you can see all this earth phenomenon. So I'm not only claiming that the sun affecting the climate, I'm talking that internally it's also related to how the volcanic eruption, because volcanic eruption also in turn affect the climate. I hope you got the whole chain down. If you don't, take a quiz. So do we know any big earthquake around 1450 or 1460? Indeed, we have seen it. This Japanese paper just came out about a few months ago that shows that in Japan Trench, you are able to, Japan Trench, just to show you the location, is very deep down. Okay, this is of the order of already a few thousand meters. That you can see that actually there's a very clear event that is very well known. It's called the 1454 Kyotoku earthquake that is quite large, 8.4 earthquake. So it does shows you that a lot of these events are not what you call accidental. I proclaim that it may have something to do with this sun-planet interaction business that I'm trying to work on. I need to take another 10 minutes to explain to you what you can see forward using this idea of integrating the whole orbits around, right? I hope your head is not spinning yet. If it's not, you just shake your head a little bit, right? Up and down, up and down. All right, let's predict the future now. Joe, pay attention, right? Let's see if you can you agree with this or disagree with it. But you know, it's orbital theory, man. It's really Newton theory. It's nothing more to that. On this topic, there's a bit of warning from this great Russian physicist who says that the greatest attention should be devoted to the question whether there is a connection between the Earth's weather and fluctuation in solar activity. Because he says that if the presence of such a connection is true, it would be a tragedy for meteorology, because it would evidently mean that we need to predict the behavior of the sun before we can predict the weather. Okay, Joe? Is that a big enough of a problem now? So, but then I want to tell you that not all predictions are created equal. There's a lot of noise in this business, by the way. There's a lot of people who want to just rush that, oh, the future of the Earth must be cool because CO2 go up, so we want to fight that like that. No, we don't need all of that. We need to find out what the truth is, right? That's my whole business of doing this work so carefully. So in newspaper, you will see, oh, mini ice age is coming. Scientists say this, scientists say that, right? And then you can see Washington Post, who doesn't like this sort of thing so much, who say, no, Earth is not heading towards a mini ice age. So yeah, every time you can create one of this noise, they can create like another counter noise. So please stop all the noise, right? Let's see what is real. Here I want to talk about a work that's very promising. Now, the first step, we need to predict what the sun is doing. Then we work out all the orbits business, right? First, what the sun is doing. What the sun is doing, the only best recommendation I have is basically based on this paper that actually Unfortunately, I was the editor for this particular paper, and this is actually one of my working colleagues, Victor Velasco from Mexico. And indeed, he was able to show using a lot of this, techniques. It's all techniques, by the way. It's all details. But showing you that you actually can retro-dig a lot of this Sporran Minimum and the Maunder Minimum, and then you can also predict that there is a coming 21st century minimum. No doubt, this thing is happening about 2030 or 2040 or so. Just to remind you that CO2 is not that powerful on Mars, right? It's all frozen ice and frozen everything. You might want to have a CO2 shave ice. Now we come to the final part where Sionso and I and two of his colleagues that we actually offer this new paper. The center of the universe is right here. So this is a new paper that we just wrote. In fact, it's all brand new, of course, because we have this brand new orbital solution that nobody wants to listen to us yet, but we will keep telling them, of course. But the first hint is that can we see any future cooling? There is no doubt. If you look in the North Atlantic now, we actually see a systematic tendency. This is based on the best, most accurate measurement we got called the Argo buoy that is actually floating on the surface and go deep down about 2,000 meters and came out, send the relay information back. The most accurate information start about 2004, and by now you can see the systematic cooling in the North Atlantic, deep down in the region. It's perhaps telling you that these things are heading towards that direction. But what does the orbital theory say? So from the orbital theory, it's very simple. We just integrate everything forward, right? And what we can see is that at high latitude region, about 65 degrees north or so, for winter, obviously, there's no sun there because the sun went to the south, right? No, nothing. But for the June insolation, there is no doubt that it will decrease, okay? And in fact, the amount is quite large. It's of the order of a few watt per meter square, right? All the way down, and then there's a dip around 2030, 2040, lasted about even up to 2080. But as we were, and then I show you same thing for other region, like other seasons, September versus March, for example, the equinox. So no wonder people are saying global warming, and then they forgot that global cooling could really be coming, right? And then yesterday, we were discussing a lot of this with the two Joes sitting behind you. We were discussing that, wow, climate system doesn't work by the absolute value. It works by gradients, so on and so forth. So we're going to show you that. The first thing we want to remind is that when it's cold, relatively cold, you actually tend to have a lot more of this extreme event, right? These things that is very well known that, by the way, Job has studied. Please ask him. He will remember precisely what happened during that day, okay? On September, during that week, 1971, where you have 6 or 5 simultaneous tropical cyclones forming at the same time, where those guys are jumping up and down, right, about all these things. By 1970, I don't think you can actually try to attribute CO2 to that phenomenon. But I would have to say that it most likely related to the insolation gradient, between how the sunlight is projected on the Earth and the difference between the equator and the high latitude region. So here I show you a quantity that we calculated for that paper. For December, you can see on the future, the gradient for the insolation is increasing, actually. So that means it's not good for the winter season. It's going to have more extreme weather. For the summer to the fall season, it's clearly decreasing. Okay, so the gradient, take it what you have, right? We need the next layer to try to say that what does it mean for the climate. But I would say that we really need that sort of information of how the Earth go around the suns and then give you all this information before we actually say what we can know about the future. But of course, we know for sure that it's not going to be governed by CO2 alone, right? So this is another very interesting thing that actually, this particular event, actually myself and colleagues, this is another topic that we have to save for other years. But I'll finish with just this slide to try to remind us that science is indeed a very valuable sort of a thing, entity that we human mind are allowed to learn, actually. And it's indeed that if you want to talk about business or future being very dangerous, like this CO2 killing all of us, I mean, we better don't talk about that too much, because we really need to let science say what it is, It is science that really going to tell us what it should be in the future, right? Okay, thank you. That's about all. If we have time, I'm happy to answer some questions.
One of the things that was most striking about what you were showing was that I always assumed, like maybe most of us, that the sun was fairly stationary.
Yes.
But you showed how it did a little wobbling thing.
Yes.
And what that reminded me of, a thing I had heard and learned a little bit about, a long time ago, long before there were telescopes, there was that phenomenon of the near pass-by of Mars that Jonathan Swift, the author, was able to actually show prior to them learning that there were moons on Mars that went in different directions. So anyway, the question I would ask could that, though Mars is so tiny compared to the sun, could that have had anything to do with causing the sun to do that little wobble dance?
Yes, I told you the amount of the inner planets, the one that is Earth, Venus, Earth, and Mars, can change the center of the movement by 1,600 kilometers. But the one by Jupiter, the big guy, because this is all angular momentum adjustment. Remember, this motion is highly complicated. That's why I'm saying, please don't take this thing. It's non-planar. You understand? There's a slight change in non-planar. Depends. Especially, in fact, they can even show effect from all the way out to the asteroid belt. For example, the one that Woods belt, that have some effects on this. What I'm trying to tell you that this thing is very, very interesting. The solar physicists, by the way, will be very deeply against this. But as a scientist, I just pursue where the evidence tells me. In fact, we have more evidence to show you why this thing is quite reasonable. So, for example, I can show you, the Venus and Earth are perturbing the sun's motion. You know what we can see that? You know how periodic that thing is? About 1.6 years. If you study the sunspot activity, you know what you see? You see 1.6 years. Tell me where that come from. No one can explain it by the general, what you call Navier-Stokes equation with Maxwell equation. You couple them to try to solve this, what you call magneto-hydrodynamics equation, right? And no one can tell you that this 1.6 can come naturally. In fact, for the sunspot, if you use a set of equation, you don't even get the number coming out naturally that it has to be 12 years or it has to be, 22 years, that sort of thing. This is why I've been stuck on that framework for a long time until I'm encouraged by the work, the high quality work by my friend Sionso. Science, you have to change your mind when evidence is not going, is not telling you. So I'm just trying to teach you. I'm not saying that this is also a definitive theory, so I'm a bit cautious. But I'm trying to tell you that the power of this thing to explain stuff, it's just amazing. It's so huge. In fact, I was so excited to tell David Legace what's my next move. Because we have a small victory this year, by the way, a few months ago in July. What you call the International Council on Stratigraphy. These are the deep geology people. Because according to this anthropogenic global warming people, they've been trying to change this word called the Anthropocene, which is really ridiculous way, okay, to say that, man come along, we dominate everything. Not yet. Not yet. You will never see that in the stratigraphy yet, okay? But those council, a group of people, very distinguished geologists, especially two of them from University of Cambridge, which I'm going to contact them, they refuse to barge in, they refuse to call Anthropocene a special period. So they issued the conclusion last month that they're going to divide Holocene, which is the last 10 to 12,000 years ago, into three parts, right? And I excited to tell you is that we're going to use this orbital theory to define this three-part self-consistently. But I believe you may need to do it about 4 parts, not 3 parts, for example, so we can give a bit more insight. So this is a chronology issue that a lot of this problem in earth sciences really depends on this, what you call the external, that's very accurate. By the way, the point about this work on orbits and all that, indeed we assume we know a lot, but the timing of it is really, really critical. And we have a lot more to know. That's why I told you, I can say that Sporran Minimum is not what people are saying, like 1450 to 15 that. I say from orbital theory viewpoint, it's 1430. It started a bit earlier. Because you can tell when the orbit started to go into regular motion and into retrograde motion, all of a sudden the sun's spin x, go the other way, the angular momentum. So it's very powerful. I'm attracted by being powerful. Again, if the evidence come out that this thing is completely crap, wrong, okay. Like I say, I'm not married to any scientific theory. I'm only married to my wife. So thank you.